Part 3. Geometry Speaks Physics. Behind it all is surely an idea so simple, so beautiful, that when we grasp it in a decade, a century, or a millennium, we will all say to each other, "How could it have been otherwise?" John Archibald Wheeler. Chapter 9. The Geometry Beneath. For centuries, the constants of nature have stood as a list of unexplained empirical facts. Hidden within that list is a coded message about the character of our universe, a message written in the language of geometry. In this chapter, we begin to decode that message, discovering the geometry that structures the rules of physics itself. At the back of this book, you will find a map called the dictionary. This is not a map of territory, but of structure. It presents all 288 constants of nature, each decoded using just two simple rules, the binomial constructor and the hyperbolic partition equation, built from 5 fundamental Planck boundaries. Applied consistently, these two rules convert every constant into a coherent geometric expression. These expressions do more than produce the magnitudes and dimensions of the individual constants of nature. They reveal the beautiful patterns that organize them. The dictionary is organized by partition structure. The first 2 columns of 36 equations define the polar transforms of the system. First 36 radial connections, then 36 radius-bound connections. The next 6 columns, 36 equations each, define the Cartesian transforms of the system, the 2-part products, 3-part products, 2-part sums, 3-part sums, 2-part quadrances, and 3-part quadrances. In Chapter 3, we explored nature's energy architecture, which corresponds to column 3, the 2-part products. In the full dictionary, we see how the rest of the constants pattern together. For example, 14 of the 2-part quadrances define recurring algebraic constructions internally set by the universal parabolic constant, pup, defining the constructive conjugate of the fixed point of our infinite power tower of I. And 12 of the 3-part quadrances define constructions structured by the QRS constant, CQ, defining the synchronization threshold in the QRS model of non-linearly coupled oscillators. To begin exploring the content of this dictionary, let's examine what it has to say about the 3 constants of nature that calibrate the physical world into a faithful realization of the Dirac equation, the speed of light, the reduced Planck constant, and the electron mass. These constants are the interface between algebra, geometry, and physics. They let Dirac's equations speak the language of nature by weaving the actions of quantum mechanics and special relativity into one coherent framework. The dictionary entry for the speed of light in vacuum, c, is From this we see that the speed of light is externally constructed from 1 Planck length divided by 1 Planck time. Internally, this construction is geometrically maintained by the square root of Giesking's constant and uses one of the hyperbolic partition equation's simple transforms, G1 minus G2, to invert along the internal inversion boundaries. This characterizes the constructive limit of velocity, and it predicts a value for that limit that is in perfect agreement with the measured value. The dictionary entry for the reduced Planck constant is This reveals the reduced Planck constant as externally constructed from 1 Planck length squared multiplied by 1 Planck mass divided by 1 Planck time. Internally, this arrangement is geometrically maintained by the square root of zeta of 2, which uses another simple transform, j theta squared, to invert about the internal inversion boundaries. This algebraic balance characterizes the atomic unit of action in perfect agreement with the measured value. It belongs to a set of 14 commonly constructed polar radian expressions. The dictionary entry for the electron mass is The electron mass is externally constructed from 2 hyperbolic figure-8 knots divided by a cubic kilogram, using 4 Planck mass boundaries. This arrangement is internally stabilized by the symmetric geometric action square root of 18 over the square root of 2 VFE, using another simple transform of the system, r cubed, to invert across the internal inversion boundaries. This geometric construction characterizes the electron mass, predicting a value for it that is in perfect agreement with the measured value. What do the geometric constraints of these 3 constants have in common? They are all critical to shaping the world into the balanced logic of the Dirac equation, and they all reveal the same underlying geometry, the hyperbolic figure-8 knot. Let's explore how. The constructive equation for the hyperbolic figure-8 knot is VFE equals I times by the difference between 2 dilogarithms. The argument in the first is 1 over the imaginary golden ratio, and the argument in the second is the imaginary golden ratio. To connect the hyperbolic figure-8 knot's volume, which structures the electron mass into form, to the geometry that structures the speed of light and the reduced Planck constant, we note that both of the hyperbolic figure-8 knot's constructive dilogarithms naturally separate into real and imaginary parts. The real parts divide into 24 modular pieces, and the imaginary parts are defined by the Giesking manifold, the minimum 3 manifold. From this, the connection among the 3 geometric constraints becomes clear. The speed of light is set by the square root of the imaginary part of that construction. The reduced Planck constant is set by the square root of the real part, and the electron mass combines those parts into 2 hyperbolic figure-8 knots. Therefore, the geometry that obeys the unitary logic of the Dirac equation, the geometry that naturally shapes together a universe that maintains the coherent logic of the Dirac equation, is the hyperbolic figure-8 knot. The hyperbolic figure-8 knot is not just any manifold. It is the simplest possible structure that sustains persistence. Among infinite possibilities, nature chose the minimal sufficient stage. Let's look even closer at the character of that stage. The hyperbolic figure-8 knot decomposes into 2 tetrahedra, and its full symmetry group is composed of 12 rotational symmetries, 12 reflection symmetries, and 2 inversion symmetries. Multiplied together, 12 times 12 times 2 equals 288. This is exactly the number of constants in nature, 288. There are exactly 288 symmetric transforms allowed by the underlying logic of the hyperbolic figure-8 knot. The constants were revealing the symmetry structure of geometry all along. The number of constants is not a coincidence. It is a geometric necessity. Going further, we note that the stage created by the hyperbolic figure-8 knot, its real conjugate, is equal to a double-covered unit sphere divided up in 288 ways. The constants of nature are systematic expressions of the internal structure of this simplest manifold. The number of constants of nature mirrors the number of internal symmetries of the minimum hyperbolic manifold capable of sustaining persistent structure. This symmetry structure is the deep architecture underlying all 288 constants of nature. It structures a world into existence with exact geometric logic. We are not discovering isolated facts. We are uncovering a system, a complete geometric structure that produces the constants of nature as necessary outputs of its internal logic. The root structure behind a physical law is geometric. The world we inhabit is a structured emanation of the simplest possible hyperbolic form capable of coherent persistence. In uncovering this hidden order, we relied on two structural rules: the binomial constructor, governing how the two layers of reality coherently combine, and the hyperbolic partition equation, governing how the system partitions while preserving coherence. The binomial constructor was a rule we observed by painstakingly examining the combinatorial structure of the constants of nature. We didn't know the reason for this rule, but we observed it to be constructively present, so we encoded it as a constraint. The hyperbolic partition equation came to us with a bit of magic, modifying de Vries's approximation for the fine structure constant by giving that hyperbolic structure a Planck mass gap. This revealed a geometric structure with an explosion of connective logic we constructively used to geometrically decode the constants of nature. But why were these two rules there? Now that we've discovered the root geometry of our system, we can ask if those two rules are structural consequences of it. Are these two rules independent inventions or inevitable expressions of the hyperbolic figure-8 knot structure itself? If they are inevitable expressions of the figure-8 knot's own architecture, then we will have found a completely self-sourced geometric engine of persistence, a structure from which all transformations and all physical laws must necessarily arise. In the next chapter, we will follow this question to its resolution. We will discover that the two structural rules, the binomial constructor and the hyperbolic partition equation, arise naturally from the architecture of the hyperbolic figure-8 knot. Chapter 10. The geometric origins of the two framing rules. A theory is more impressive the greater the simplicity of its premises, the more different kinds of things it relates, and the more extended its area of applicability. Albert Einstein. The constants of nature have long stood as monuments to a structure yet to be uncovered. Now we find them perfectly organized by two simple rules, the binomial constructor and the hyperbolic partition equation. The binomial constructor unifies two different layers of geometric action, external and internal, into one coherent structure. The hyperbolic partition equation governs how that structure partitions inside its mass gap, preserving balance through coherent transformation. But are these two rules inventions, patterns we imposed upon nature, or are they necessary consequences of the deeper structure we uncovered, the hyperbolic figure-8 knot? The hyperbolic figure-8 knot is a manifold that decomposes into two ideal tetrahedra, stitched together by a modular network of reflections and inversions, forming a double cover, two interwoven relational layers bound into one coherent manifold. This structure is not flat. It creates a layered, self-mirroring geometry. Each action reflected across an internal inversion boundary produces a mirrored counterpart, preserving overall consistency through two interwoven layers. This is the essence of being a double cover, organizing into two relational layers, one outward, one inward, combined into a coherent whole. The binomial constructor, our rule for coherently balancing external and internal actions, mirrors this architecture precisely. Every measurable action arises from two contributing geometries, an internal geometric action, observable, expansive, and an internal geometric action, organizing, foundational. These two layers do not simply coexist, they co-construct each other through a binomial relation. Just as the hyperbolic figure-8 knot binds two mirrored tetrahedra into one coherent manifold, the constants of nature bind two modular contributions into one measurable quantity. The binomial constructor is a natural expression of the hyperbolic figure-8 knot's native double-cover logic, expressed in Planck boundaries. The hyperbolic partition equation also finds its origin here, but through a beautiful twist. If we take the hyperbolic partition equation and separate its left and right parts, we discover that they are both just one modification away from being structural projections of the hyperbolic figure-8 knot. Reducing the left side of the equation, transforming its 2 pi to a 1, yields an equation for a hyperbola. Setting this hyperbolic structure equal to 0, we reveal its four solutions, or roots, as the hyperbolic figure-8 knots dilogarithmic arguments and their squares. This reduced equation traces out the projective structure of the hyperbolic figure-8 knot. That form is then modified in one way, dividing one term by 2 pi, adding a single complete term to one of its parts, representing a once-twisted boundary defining the closed and connected partition structure that coherently connects the single and double cover in the system. That is, the rule that captures the partition logic of the constants of nature defines the once-twisted zero boundary created by the hyperbolic figure-8 knot itself. This boundary defines the partition structure that coherently fits the first and second layers of reality together. To match this change on the left side of our equation, we twist our 0 on the right side of our equation. That is, we take the zeros constructively present in the dilogarithmic structure of the hyperbolic figure-8 knot, and we reconfigure those symmetric dilogarithmic components so that they close upon each other, capturing the once twisted boundary of the knot. The magnitude of this twisted zero boundary defines the difference between the dilogarithmic full cycle and the dilogarithmic half cycle, the same dilogarithmic cycle created by the hyperbolic figure-8 knot. Now that we know what the hyperbolic figure-8 knot's zero boundary becomes once it's twisted to invert and connect with itself, we replace the 0 on the right side of our equation with the hyperbolic geometry scaled by this once twisted zero boundary. Finally, we set the scale of its mass gap equal to the Planck mass, representing the size of the gap between the hyperbolic structure's two-sheeted hyperboloid. Thus, we arrive at the hyperbolic partition equation derived entirely from the hyperbolic figure-8 knot's zero boundary, once twisted and anchored to the Planck mass boundary. Both of the framing rules that structure the constants of nature are expressions of the architecture of the hyperbolic figure-8 knot itself. What about the Planck constants? Earlier, we defined the Planck constants as hyperbolic plane waves, quantized structures fitting the larger architecture together. Can we now understand the deeper geometric home of those Planck constants? The conjugate of the hyperbolic figure-8 knot does not exist in isolation. It is enclosed, embraced, and stabilized by a second, larger arena, a higher dimensional lattice of extraordinary symmetry, defining the transform space available to it. Surrounding the real conjugate of the hyperbolic figure-8 knot, which squarely divides a unit sphere into 24 pieces twice, there is a second, inverse geometric structure defining the transform lattice available to that geometric core. In the next chapter, we will step outward from the hyperbolic figure-8 knot at the center to the even unimodular 24-dimensional lattice that surrounds it. There we will find the hidden framework of the Leech lattice and the final key to understanding the larger structure where the Planck constants emerge as quantized plane waves threading together the symmetries of atomic logic.